Hi, this is a really quick video going through the examples in class from 9:15 for my third hour honors trig pre-calc because of the Wi-Fi issues. So you may or may not need this video, but I'll do it anyway. The first example is perform the operations and write the results in standard form. So we are adding and subtracting like terms here. 9 plus 1 is 10, plus 7 is 17. That's the real piece of this. And then we have 2i minus 3i, which when you simplify it, you get minus 2i. So 17 minus 2i is the full answer here. That's really it. For the second one, the only thing I want to point out is don't distribute that squared, right? We actually have to FOIL. 1 plus 4i times 1 plus 4i. So we start by first, 1 times 1 is 1, outside plus 4i, inside plus 4i, and last plus 16i squared. We can simplify a little bit. 4i plus 4i is 8i. Oops. Sorry. We have 1 plus 8i. I squared is really a negative 1, so this is actually minus 16. And last but not least, 1 minus 16 is a negative 15 plus 8i. Again, that is our final solution. Notice, just like the first, we have it in that standard form, which is a plus bi, where a is the real part, b is the imaginary. The second example we had was simplifying, and the only thing I want to note for you guys who were not in class, and maybe you didn't hear this, is that you cannot divide by a complex number. And so how do we get rid of this division? Well, we are going to change that complex number into a real number. So we want to change into a real number, and we do this by multiplying by its conjugate. So 1 minus 2i. And technically what we're doing here is, since we're going to multiply both the numerator and the denominator by the same thing, we are technically multiplying by 1, right? Anything over itself is really 1. So when I simplify here, I'm going to distribute the 5. So I would get 5 minus 10i, that's the numerator. In the denominator, I need to FOIL. So first, 1 times 1 is 1. Outside, minus 2i inside, plus 2i, and last, minus 4i squared. All right, let's do a little bit of simplification. The numerator, 5 minus 10i, all over. Notice that the plus 2i minus 2i's are going to cancel. I squared is really 1. So technically I have 1 plus 4, or 5. So I have 5 over 5 minus 10i over 5. But of course, we wouldn't write it like that. We would really write 1 minus 2i. So that's our first one. Lovely. Let's look at this second one. Let me extend the page a little bit. All right. So we got to do the same thing. We have to multiply by the conjugate of the denominator. So 2 plus I. And if I do it to the denominator, I'm going to also multiply the numerator. In the top, we need to FOIL. So 6 plus 3i plus 2i plus I squared all over. In the denominator, 2 times 2 is 4. So then it would be plus 2i minus 2i minus I squared. All right. These become a 5i. This is really minus 1, so I have 5 plus 5i. All over, these guys cancel. This is a minus 1, so we really have a 5 down there. And this makes it 1 plus I. Good job. The last example was this little guy, and it said solve, and I specifically asked you to use the quadratic formula here. So x is equal to negative b, so 2 plus or minus the square root of b squared, negative 2 squared, minus 4 times a times c, all over 2a. So we really have 2 plus or minus the square root of 4 minus 4 times 5 is 20. 20 times 3 is 60. All over 6. So I have 2 plus or minus the square root of negative 56 over 6. And while that's technically correct, we would never keep it like that. Let's start by writing it as 2 plus or minus the square root. This is really 8 times 7, and then I'm pulling out an I, right? Negative 1 times 56, that's the square root, and the square root of negative 1 is really I, so we have the square root of 56I, all over 6 still. 8 is really 4 times 2, so I technically have the square root of 4 times 2 times 7 there, and because 4 is a perfect square, we can pull that out. So we get 2 plus or minus 2, that's from the 4, times the square root of what's left over. 2 times 7 is 14. Still have that I all over 6. And then my last move is really just to break it up. So I really have 2 over 6 plus or minus 2 square root of 14I over 6. And of course I would make that a lot nicer. 1/3 plus or minus the square root of 14 over 3I. I like this answer more than what we had above, because technically this is 1 plus or minus the square root of 14I over 3. And this is technically a correct answer, but I like this one more because it's in that standard form, right? The A plus BI. We have the real piece and the imaginary piece. All right, sorry for the issues today, ladies. I will see you tomorrow.